Perseverance mission and find out whether we are any closer to discovering signs of ancient fossilized life. As the rover turned on its cameras and took in its surroundings for the first time, it found itself staring out across the red, arid and solitary landscape that we have come to expect from Mars. The terrain around it was mostly flat, albeit interspersed with rocky outcrops. This was intentional. Scientists had deliberately brought Perseverance to a place where its wheels could transport it freely, and where it could find sites of particular scientific interest. To that end, they had chosen Jezero crater. Some 45 kilometers wide and just north of Mars's equator, Jezero has existed on Mars for at least 3.5 billion years. Showing signs of ancient deltas, it seemed like an excellent place to begin the search for ancient alien life. Such life might only have reached the level of bacterial organisms, and so the clues as to their existence might be similarly tiny, making this search all the more difficult. However, scientists would be on the lookout for signs of any formations in the rock that could not be reasonably explained by geological processes. This might offer tantalizing hints or even definitive proof of ancient Martian bacteria. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods without needing to do major drilling, helping scientists piece together the geological history of the Jezero crater and to get a better picture of the most likely locations to find life. You would think that Perseverance would be on the move almost immediately, eager to begin its mission. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods, giving it plenty of opportunity to get started on its search. However, you would be wrong. Despite landing on Mars in February, it wasn't until nearly 5 months later that Perseverance made any major effort to leave its landing site and begin its journey. And this was not just because scientists took time carefully testing every single piece of scientific equipment and its software to make sure everything was working smoothly. You see, Perseverance was not alone. In fact, it may surprise you to discover, but you might say it was because Perseverance was pregnant. Cradled in Perseverance's undercarriage, hidden by a dust shield from the Martian winds and atmosphere, Perseverance had brought with it a second, smaller passenger to Mars. And much of the initial few months of Perseverance's time was spent helping bring that second passenger into the world. This second passenger was to be Perseverance's companion for the journey ahead, as well as an interesting tech demo. This smaller robot was not a rover. Its name was Ingenuity, and it was the first ever attempt at a helicopter on Mars. After performing several tests on Perseverance's own software and hardware, scientists turned their attention to this smaller 1.8 kilogram drone. The atmosphere on Mars is about 100 times thinner than Earth's, making it uncertain whether a helicopter's spinning blades would even work there. It would be difficult to displace enough air to create lift. Ingenuity was incredibly lightweight to compensate for this, and its rotor could spin at revs of over 2,000 RPM. Its only scientific equipment was a camera, but this would be invaluable in helping Perseverance find the best routes through the potentially tricky Martian terrain. So, on the 21st of March, nearly a month after landing, the birthing began. Perseverance started by removing its dust shield, allowing Ingenuity to taste the Martian air. Mechanical birthing is a slow process, however, with scientists constantly checking every single piece of data to make sure everything is functioning as it should. It wasn't until the 3rd of April that Perseverance finally placed Ingenuity on the hard Martian soil and allowed it to experience its first cold night on Mars. Temperatures on Mars reach lows of minus 100 degrees Celsius, so outside of the protective heaters of Perseverance, it's no small thing that Ingenuity survived the night with no problems. But scientists were delighted that this part of the mission went smoothly. During this stage of Perseverance's mission, it looked on like a proud parent as Ingenuity began to take its first wobbling steps. Although, just like a parent, Perseverance couldn't resist taking a selfie or two to show off to its friends on Earth. Ingenuity's first flights did not go completely without a hitch. After taking time to test its rotors at varying speeds, Ingenuity did run into some software issues that worried the engineers who'd worked on it. However, by the 19th of April, Perseverance was able to record as the solar-powered drone attempted the first ever controlled flight on another planet. The flight was done autonomously, as the time it would take for a signal to travel from Earth to Mars would create too much lag to try and fly remotely. And there were a lot of unknowns. Mars has a lighter gravity compared to us, as well as having thinner air, which meant that testing the rotor on Earth didn't necessarily mean it would work on Mars. It's hard to properly replicate lower gravity on Earth, for example. But fortunately, and with incredible smoothness, Ingenuity rose to an altitude of 3 meters and remained hovering there for 39.1 seconds, just as planned. Scientists were very excited when the tech demo that had been proposed just 6 years earlier had proved itself a success. Ingenuity was not expected to last long on Mars, but it kept going and going, flying further and higher than every previous attempt. It didn't crash, didn't break, and actually has become a useful scout for Perseverance, to find good routes for the rover to take, or to search for points of interest too small for satellites to detect. Ingenuity went from a disposable tech demo at the beginning of the mission to a valuable aid and accomplice for the Perseverance rover. What about Perseverance? The Martian rover was not completely idle during this time. Perseverance was able to test out a lot of its own gear while it waited for Ingenuity. Perseverance was equipped with a microphone, and scientists hoped to get the first ever audio sample from the Martian surface. Soon after landing on Mars, Perseverance was able to do just that, giving us our first idea of what the wind on Mars sounds like. It certainly adds to the desolate feel of the landscape. If you remember the audio file from the InSight mission and others, they didn't come from a microphone, but they were rather audio converted from the vibrations of the wind over InSight's solar panels. Check out this video if you want to hear the difference. Perseverance also spent time driving short distances to test its motors, took panoramas of the surrounding landscape, and even successfully extracted oxygen from carbon dioxide out of the red planet's atmosphere using its MOXIE instrument. This vital achievement is more significant than you might think. Not only will it be incredibly useful for colonists that might want to live on Mars to know that they are able to produce their own oxygen there, but a ready source of oxygen has another use you might not expect: rocket fuel. Leaving a planet's gravity naturally takes a lot of fuel. For Mars's lighter gravity, it still requires 30 to 45 metric tons of propellant, depending on the payload. Leaving Earth is already hard to do, and becomes harder still if you have to also carry all the fuel you'll want to make the trip home again. However, knowing that we might be able to make most or all of that fuel from liquid oxygen makes space travel between planets much more feasible. MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment, managed to produce about 10 grams of oxygen in 1 hour, which is not that much, but to be fair, MOXIE is only a prototype about the size of a car battery. It would need to be 100 times larger if we're to actually use it on the Red Planet to support human interests. However, just knowing that it works is an exciting step forward. But as fascinating as all these things are, there was one thing that Perseverance still needed to do. It had come here to discover one very important thing: was there ever life on Mars? And so, during this period of downtime, scientists were busily plotting the best possible route for Perseverance to take. Although Perseverance's landing was one of the most accurate Mars landings NASA had achieved so far, it was still many days' travel from some of the 40-meter tall outcroppings of a rock at the edge of a crater known as South Sitar that scientists had wanted to investigate. And between South Sitar and Perseverance's landing site, there lay a dangerous dune field filled with loose sand, impossible for the rover to cross without risking getting stuck forever, which would spell an end to the mission. Scientists would need to decide the best possible route around the dunes. Was it better to travel anti-clockwise around the crater, which would get Perseverance to the outcroppings faster? or would it be better to travel clockwise, which would take longer but would allow the rover to stop by more interesting rocks along the way? In the end, as is often the case in space exploration, it came down to efficiency. Scientists chose the second option, to allow it to do as much science as possible in as many areas as possible in the limited time the rover had available to it. Perseverance was finally given the go-ahead. And so, on the 1st of June, almost 5 months after arriving on the Red Planet, Perseverance's wheels trundled into life, and the rover finally left the safety of its landing site and set out on its primary mission, to collect core rock samples from locations life could potentially have flourished, for ultimate return for analysis to Earth. The search for alien life could now begin in earnest, with Ingenuity following along to keep Perseverance company, of course. Subscribe for the next video coming soon. Air, water, food, electricity and fuel are all essential to explore the solar system, which is what made the MOXIE experiment so important to bring along with Perseverance. We need to perform these experiments before we can think about sending actual humans to Mars. So what have we done to overcome some of the other challenges other worlds pose? Well, there really are some innovative solutions that I've seen so far. I was watching a documentary on Magellan TV called Mars, Adapt or Leave, which investigated what we have done so far and what still needs to be done